This is lab number 2, chemical kinetics. And this would be like a post-lab discussion.
Okay, we did a pre-lab discussion, I think. So we've got, let's see, another chat. Oh, okay. All right. We did the pre-lab questions last time, didn't we? So when we actually did the lab. Oh, your microphone won't work. Okay, good. So we just need to deal with the data that you received. Okay. So I wish I had that with me, then I could use real numbers, use your numbers. I thought I had put that together, but I don't see it here. All right. So let's start off with calculating the concentration of the bleach. We had, you gathered data on the bleach in terms of what's the mass of so many drops of bleach. Right. So you had, I'm going to have to use an example different than yours. So let's say we have that mass per 50 drops. Okay. That's not a good one. Hold on a second. Shoot. Let me search my files here for a second. You know what? In fact, I'm going to share. Hold on. Let me open up the, let me close this one. Escape that. And close this right here. Close that. Okay. Because I've got some data from Beckley that I think would be helpful if I could just find it. Okay, let's see here. And here. I'll tell you what, before I do that, I'm going to look. I'm going to look for this particular course, the one we're in right now, and see if I've got it in here. I just didn't print it out. That's possible. Okay. No, I've done the molar mass. Let me open this one and see if it's different. No, I haven't done your kinetics data yet. Okay, so let me go pull up some kinetics data from my class in Beckley, because we did the same procedure and got the same types of data. Let's see, right here, and 104 here. Okay. I want to get this year's data. Kinetics results. Okay, that's the raw numbers. I don't need those. What I need is, here we go. Look at this in Excel. Here we go. No, that's the wrong year. Where is it? These calculations. Okay. I had an Excel file. I had to have an Excel file to do this. Here it is. Okay. Okay. Now that I got this open, I'm going to share it. There we go. Yeah. Okay. So let me go back to the Zoom session and share that, which is right here. There we go. Okay. So this is some data that we got in Beckley with my class. And notice that we collected both mass per number of drops and volume per number of drops. So to calculate the effective moles of sodium hypochlorite per drop, you use this procedure. You have 6, and this is like the pre-lab question that we did earlier. That's how many moles of sodium hypochlorite that you're adding for every drop. And that's for 79 drops, but we didn't add 79 drops, right? You added a smaller amount per 3 mLs. So here we have the adjustment to 18 drops of bleach for 3 mLs was there. 30 drops was what they found to be a 3-minute decolorization. And I don't remember what yours was, whether it was 30 drops or 40 drops or whatever it is, but that's how you would calculate how many drops of bleach you added. And that should already have been done anyway. But we need to know that, how many drops of bleach. Well, if we know the, we also, with this milliliters per drop, we found that we added this many milliliters per drop. So if we actually add 18 drops of bleach to the reaction vessel, then this tells us how many milliliters we added to the reaction vessel. So the total volume in the reaction vessel was 3 milliliters plus this value. Okay, you need to know that. You need to know the actual volume in there so that you can calculate the bleach concentration. So the full strength bleach, now you need to say, okay, how many moles of sodium hypochlorite per drop? And then how many drops did you add? Okay. And then you divide that by the volume in liters, and you get, this is your molarity for the full strength bleach. Okay. And then the half strength obviously is just 1/2 that. So that's where the bleach calculation comes in. Then, once you know the bleach concentration, we need to go back to the blue dye. Say, all right, what is the order for the rate law in terms of the blue dye? Right? Remember, we had erase this. We wrote our rate law out as the rate. Try this one. The rate equals a rate constant times the concentration of the blue number 1 to some order times the concentration of sodium hypochlorite to its concentration. Okay, that's the overall rate law without the values in place. Well, remember we said that this has to be, we have to fix this so that it doesn't change during the reaction. So we make the concentration high enough so that it won't change. And to do that, we had to combine this one and this one. Since this is constant now, and this is constant, we combine that into a rate expression where those two values become K prime, a new rate constant. Now we can deal with only one change. We know how to determine the order for this one, right? We take the time versus absorbance, right? Time versus absorbance. If we calculate these two, we plot these two, and then we take the natural log of A, and we plot those two, and then we take the inverse of A, absorbance, remember, and we plot those. Which one gives you a straight line? Right? Once you find out that, this is zero order, this is first order, and that's second order. Then you have a value for that, right there, or that one right there. Okay? Now this K prime, let me put it over here, just as a reminder. K prime is equal to the K times the concentration of sodium hypochlorite to the M power. All right. So we do this for both concentrations of sodium hypochlorite. So we'll have a K prime for the full strength, and we'll have a K prime for the half strength. That's still equal to K, only now the concentration, this is full strength, this is half strength. But the order is the same, right? So you got those two expressions, and we've calculated the concentration of these two, right? Okay. So once you've got this, once you've determined that value, then let me see, let me share another. Let's see. Yeah, let's use this group right here. Come on. There we go. Once you've used that value, now we have this expression right here. And if you determine that it's the first order right here, then you'll have, hold on a second, and get something that'll write. If it's first order, if that number is 1, then you will have a plot for both full strength and half strength. One for the full strength, one for the half strength. And you'll have absorbance here, and you'll have time here. And it will be a, absorbance decreases over time. It'll be a negative slope, like this, okay? Now, if you're able to plot this in Excel, then this is what it would look like. You will have a trend line here, and you can tell Excel to also include on the graph the equation for that line. Okay, if you do that, then you got that plot there, and let's see, this one is minus 0.0118x. And then the intercept is 0.976, say. Minus 0.976. Is that a minus? Yeah, it's a minus. Okay. So you know what this is supposed to be, because this is excuse me. This is going to be minus the log of A. That's what that means. And this is minus, let's see. minus the log of A0. This is the important part right here, that one. Oh, excuse me. No, I'm wrong. I'm sorry. It's minus K times the log of A. So X is the log of A. And this is a K value right here. So K for the full strength is 0.0118 for that example. Okay. We have another example for the half strength. I just go down here and I plotted the half strength, and that is 0.0052. Okay, so this is full and this is half. Now, these are actually K primes because we're plotting this data right here. So those are K primes. So you would put this value in here, right there. This would be 0.0118 equals K times the concentration of sodium hypochlorite, which was what? Well, actually, you know what? All we need to say is this is 2 to the M. And underneath it, we're going to have the other one, 0.0052 equals K, and this is 1. Now, why can I do that? Because of the way we calculated them. We calculated this value, the actual value for the concentration of sodium hypochlorite, and then we just cut it in half for this one. So the ratio is always going to be 2 to 1. Right? So this one cancels, and this is 2 to the M, and this is equal to 0.0118. Let me do that calculation quick. 0.0118 divided by 0.0052, and that's 2.27. 2.27. So what power of M gives you 2.27? Well, it's pretty close to 1, right? First power. But if you want to be exact, then you got to calculate it. So if you want to do that, then I'll show you. The best way to calculate an unknown, if it's a power, is to use logarithms. So we're going to take the log of both sides. The log of this equals, and if you take the log of something to the power becomes a coefficient. So it's M times the log of 2. Okay. Now all we need is to take the log of those two values and solve for M. Let's see, 2.27. I'm going to take the log of it. And that's common log. That's not natural log, common log. So this one is 0.356. And this log, M times this log, is log of 2, is 0.301. Right? So M equals 0.356 divided by 0.301. Right? So M equals 1.18. Okay? So now we know that this one is equal to 1, and this one is equal to 1.18. Okay? Now, what's the true K? Well, by definition, we said that K prime is K times the concentration of the strength of sodium hypochlorite to the M value. So we can use either one of those. So we can say K prime for the first one is this one, 0.0118 equals K is your unknown. Concentration of sodium hypochlorite, the full strength, is 1.846, let's say, 1.846 times 10 to the, I lost my excuse me, lost my place. -1 molar. And that's to the m power, 1.18. Okay? So now we just have to solve for K. So we'll take 1.846 exponent -1, and we'll take that to the 1.18 power. Okay. My calculator, if I put in a number, put this number in and enter it, and then I put this number in behind it, then all I have to do is say, click the button Y to the X, and it will calculate that value. If yours will not do that, then you have to go to logarithms and say the log of this, the log of that, and go through that rigmarole again. But if you have the capability to do a number, any number to any power, then use it. In this case, I'm going to click that right there. And this is 0.1362 from that right there. K times that, 0.0118. So now I divide this one by that number. And K equals 8.66 times 10 to the -2. Okay. So if I substitute in here for K, 8.66 times 10 to the -2, that's the complete rate law. This K times blue to the 1 power times sodium hypochlorite to the 1.18 power. For this example, you'll have to use your real numbers to get there, but that's the process for determining both the orders and the K. And this is all being recorded, so if any of that blew by you, you can go back and look at it as soon as I post the video. Let's see, were there some post-lab questions in there that we need to deal with? There's pre-labs, okay, post-lab. Sometimes the post-lab questions actually tell you to do something that you've already done. So if you run into any questions like that, let's see. Okay, I'm just looking at the post-lab questions. No, those are all independent. All right, so you have any questions about the post-lab questions, if they're confusing or not? Let's see, let me stop this share so I can pick up any chat. No, okay. By the time you turn in your reports, I will have processed your data. And then I can check your answers and give you a more realistic assessment. Let's see. Okay. Yeah, if you are proficient with Excel, it really simplifies things. I don't know what else to tell you. Otherwise, you've got to hand draw this stuff and determine the slope of that line by, once you've drawn the straight line, then you've got to pick 2 points on it and do rise over run. And that will give you the slope of the line. You don't need the y-intercept. It just, if you use Excel, it gives it to you. But to do these calculations, you only need the slope of the line. Okay. Well, I'll see you in 2 weeks if I don't hear from you before, and that's all right, I'll respond as soon as possible if you have questions.